Okay, this is section A for the chapter 7 test. So here we have the fourth root of 32. So we have to remember how to simplify a radical when we just have a number inside. We don't just calculate the fourth root of 32 in the calculator to get some decimal. We want to see what number to the fourth power can go into 32. So I just got my calculator out, and you usually use those half sheets of paper, so we're going to try going without that. So this is 2 to the 4th. So 2 to the 4th is 16. Does 16 go into 32? Yes, it goes into it twice. So what I'm going to do is write the fourth root of 2 to the 4th, and 2 to the 4th is equal to 16. And 16 times 2 will give me 32. So this 2 to the 4th is 16 times 2. So remember every group of 4. So we're in the fourth root, so we're looking for groups of 4. There are 4 2's. So I just take 1 2 out. And what's left inside is this other 2. Okay, let's look at number 2. So it's the same thing. We have the cubed root of 108. So I want to see 2 to the 3rd, 3 to the 3rd. We're looking at our numbers to the 3rd power. So 2 to the 3rd, if you don't remember, is 8, or if you never remembered. 3 to the 3rd is 27. 4 to the 3rd is 64. 5 to the 3rd is 125. So 125 is way too big and cannot go into 108. So now we're going to see which of these numbers, we want to see what's the biggest number that can go into 108. So I'm going to have 108 divided by 64. That doesn't work. We have a decimal. How about 108 divided by 27? So that works. We have a whole number 4. Okay, so 27 is the winner. And this will be the third root of 3 to the 3rd, which is 27, times 4. Okay, so I have a group of 3 3's. Remember, 3 to the 3rd is 3 times 3 times 3. So I have 3 3's. So I could take 1 3 out, and left inside the radical is this 4. Okay, let me circle these answers. Okay, so number 3. Now we have variables and a number. So remember, with variables, we're trying to find how many groups of 3 again for here, because we have a third root. So 27 is 3 to the 3rd. That's what we just found here. So 3 to the 3rd is 27. I have x to the 3rd, so that's a group of 3. Y to the 6th, I want to break it down into groups of 3. So y to the 3rd, so 3 plus 3 is 6 y's. And then z to the 9th, we have z to the 3rd, z to the 3rd, z to the 3rd. 3 plus 3 plus 3 is 9. So everything with the exponent of 3 can come out. So 3 can come out of the radical, x can come out of the radical, 2 y's can come out, and 3 z's. And that will be our final answer. So see how there's nothing else left in the radical. Everything came out for that one. Okay, number 4. So we have the 6th root of x to the 6th, y to the 7th, z to the 10th. So you might get confused because you see a 6 in the 6th root. But remember, we're looking at exponents. We're not looking at the bases. 6 is a base. So there is not a number to the 6th power. So if we do 1 to the 6th, that would just equal 1. If I did 2 to the 6th, 64. So nothing other than 1 can go into 6. So 6 just stays the same. Looking for groups of 6. So x to the 6th, y to the 6th, plus 1y will be y to the 7th, z to the 6th, plus z to the 4th. That would be 10 z's, so 6 plus 4. So everything with the exponent of 6 is what comes out. So here, remember alphabetical order, 1x, a y, a z, and left in the radical is 6, y, and z to the 4th. And that would be your final answer. Okay, now let's take a look at number 5. So now we have a little mixture of things going on. We need to simplify these roots and then see if we can combine them any further. So remember, if there isn't anything in the radical here, there's a 2, an invisible 2. These are our square roots. So I want to think what number squared can go into 18. Well, 2 squared is 4. 4 doesn't go in. 3 squared is 9. 9 does go into 18. So 3 squared is 9 times 2 is 18 plus. For 200, so again, we're trying to find the biggest number that can go in, and 100 is a perfect square. It is 10 squared is 100 times 2 would go into 2 is equal to 200. So here, since it's square root, we're looking for our groups of 2. So I could take 3 out of this first radical, and we would have square root 2 plus, then this 10 can come out of the radical, and it would be square root 2. So at this point, if these radicals were not the same, we would not be able to go any further. But here we have the same root 2. So since those radicals are the same, I can add what's in front. So 3 plus 10 is 13, and then we keep the root 2. Okay, the next one is similar to number 5, except we have some variables. So the third root of 4a to the 6th, so we're trying to simplify what we have first. 4 would stay in the radical, because nothing to the third power would equal 4, other than 1. A to the 6th, I can rewrite as 2 groups of 3. Let's now move on to this next one, third root of 108. Well, let's see, wait a second, we just did 108, right over here. So this would be 3 to the 3rd times 4, so that's for the number. And then we have a to the 3rd, so that is a group of 3 a's already. So what comes out of this first one? Well, 2 a's, so a squared, and then we have the third root of 4, plus 3 will come out of this radical. We already have an a in the front, and we're taking an a out of the radical. So if I'm taking an a out of the radical, that would give us 2 a's, and left inside the radical would just be 4. So 2 a's I can just rewrite as a squared. And don't know why I put a plus sign there. So it's 3a squared, third root of 4. So now we have the same radicals, so just like before, so that means I can add what's in front. A squared is like a 1, a squared plus 3a squared, so 1 plus 3 would be 4, a squared. So remember, when you add with your variables, exponent does not change, it stays as 2. And then I have the third root of 4. Okay, number 7 and 8, that's when we're rationalizing. So if I rewrite this, it would be the square root of 4x over the square root of y. So square root of y, we're trying to get rid of the radical in the denominator. So remember, square root means we have that invisible 2. I have 1y, so how many more do I need to get it out of the radical? So I have 1, I would just need 1 more. And that's what I multiply by, the square root of y. Okay, so on top we'll have the square root of 4xy. On the bottom I'll have the square root of y squared. On the top we can reduce a little more. Square root of 4 is 2, and x and y stay in the radical. And then on the bottom, square root of y squared, the radical cancels out the exponent, and we're just left with y. Okay, and number 8. So again, I'll first rewrite this as the 4th root of 3y over the 4th root of x squared. Okay, so we're trying to look for groups of 4 to get out of the radical. So far I have 2 x's. How many more x's would I need to get rid of the radical? I would need 2 more. So that's what I'm going to multiply by, is the 4th root of x squared, because I just need 2 more x's. Okay, on the top it would be the 4th root of 3, and I'm just going alphabetical order, 3x squared y, over, this will be the 4th root of x to the 4th. And again, our radical cancels out this exponent, and we end up with 4th root 3x squared y over x.